We all know this place.
Oh, yeah.
Oh, look at this. You know what this is? This is red sandstone that somebody came along and carved. That's what this is.
Yeah.
Some
chiseling
melted steps.
That's why you got this. Yeah.
Yeah, brick.
Yeah.
Yeah, because you can compare these amphitheaters or whatever to the ones they suppose they build with brick, and they're exactly the same. And you got all this brick. Why in the hell are you chiseling this? Which is
Yep. Scroll in on the amphitheater steps again, because who the hell is carving melted fucking steps? Okay. It's not melted steps. I mean, they're not carved melted steps. They're brick steps that have melted. And there's the brick right there. Boom, baby.
Yeah.
And they call this red sandstone now.
Yeah, we can.
You can see in those steps how it flowed. You can see them drooping from the right to the left, the angulation of them.
Yeah.
You can tell that's melt.
Yep. All day long.
Yeah, I have my video of ice cream melting, and
yeah, that was great.
because it's the same process. It melts from the bottom, and the top part, it doesn't melt. It stays the same until it gets to the bottom, and then it's melt.
Yeah, and then right there where your cursor is, Shipu, where those apertures are, those windows, you can see that redder material, that red brick right there. The heat's expanding right there in that corner. Yeah, you can see that heat coming up. Just drop the pick a little bit more, right there.
Yeah.
Oh yeah.
In that slot. Look at that melt.
Yep.
Yeah.
You can see it running right down the wall, and that would cause that rock curtain type look that makes it look like it's one solid rock, and they'll convince you through geology that this is sandstone.
This must be a building inside. You could probably punch a hole somewhere and go inside this thing. Just like this. Because it wasn't built like this. Probably there was a street on the side here that
that sank down into the melt.
Yeah. Exactly.
All of it.
This is a good example here, because this looks like big blocky chunks that look like it's on the ground of the streets of Pompeii.
You can clearly see the red brick in the corner, and still some here. And
look at that big rock on the side of the wall there. Right there, that one. That was bricks, guys. They kind of melted into each other and formed one big rock right there.
Yeah.
And I just wait. I will sort by modified date, because I have no. Sorry. 2 seconds.
Oh, you're good. Take your time.
Backwards. I feel like there's some stuff I found not so long ago, and again, can clearly see that all this was bricks.
Yep.
Because we don't build like this, All the mortar just fell off, cooked off, or mixed with it.
They built today to look like that with only one and half the rocks. They cut the rocks and they put them on the blocks or whatever. And, they don't stack them like that.
And this is somebody, a cuntologist, shared this.
Yeah.
On his Facebook page. Look at this.
Wow.
Yeah, you have found the same thing. Like,
they're all fused together.
Yeah.
The bottom one's turning black too.
That is a perfect example of showing how brick turns to what we call rock. Okay, you got the brick, and then you got the melted brick right here.
Yeah.
There you go. That's good, Shapu. I like these.
Yeah, this comparison I made this week is so crazy.
Yeah, so we were looking at Ape Cave on the last live stream called Faking Volcanoes to Fake His Story. And Ape Cave is at Mount St. Helens. They'll say that this is some kind of cave. They're not saying it's a lava tube, as far as I've read, that this is a natural cave system. And then you have London sewers right here that look identical to that.
Yeah, it's identical. It's just crazy. Even the lines of colors are identical.
Mm-hmm.
Well, you see that heat coming up from the bottom there on that one, the London sewers pic. Yeah.
Yeah. It's coming up here and here.
Scorching along the top, brick lines. Oh, yeah. It's all there.
There's no denying it.
Mm-hmm. Yeah. Once you know what you're looking at and you've looked at enough of this stuff, you know what you're looking at, and there's no mistaking it.
Same type. You can clearly see the brick lines here. Yep. They same thing.
The left side looked like the right side at one time to a point. I mean, as far as
Yes.
Boom, baby.
This is, I don't know how you cannot not see it.
I love how they say that these are carved, but then they're bricked. But then they're carved, but then they're brick.
Yeah.
Yeah.
Look at it. Wow.
And now they say, oh, they just put like walls inside a mountain. Now the whole mountain was the structure.
That's right.
This is what people don't get. They don't get the immensity of the structures.
So everything above that archway there with the hole in it looks like solid rock.
Yeah.
Right? So you go above the arch, it looks like a solid wall of rock. But it's not. It's the rest of the building that is melted. And now it looks like one big wall of stone. Okay? Yes. Whatever type of stone geologists want to put a label on it as. But it's all just cooked out melted brick. Just like the streets.
You can see the steps here going up, but now it's nothing. And here.
And you can see how those steps buckled in the melt.
Yeah. Just crazy stuff. Again, I think it's the same place that I showed earlier, but another part of the wall. Look how it came up in the bottom. And I can say
let's stop right there. Stop right there. Okay, on this, towards the left, you can see where the mortar's still around the bricks right there. That little spot, just a little, right there. You just went right there. Okay, right there. That looks like the boulder that they just pulled out of that river that I showed you at the beginning of the stream, where it had those big clumpy patches of what looked like mortar around it, and then the blacker spots with the brick in the middle.
Yeah.
Yeah, Mr. Super Sidewinder, you're absolutely right. Oxyacetylene won't get you there. That's a gas heat. That's a mixed gas heat. That's not going to get you there. This was an electrical discharge event.
Yeah, and I can say that by looking at a lot of pictures and what the elites want to change the history, that there's some place that they came and they blow the shit out of stuff, and it created a lot of heat and pressure with bombs, and they created the same type of effect at other places, and that's why maybe you see some places that the top is all mangled but the bottom is not, because they dropped something. And
it could be.
What show I did that I showed that they were coming with these giant battleships and ships and leaving, and then when they left, everything was mangled and destroyed.
Yeah,
we know that they did this in a lot of places, and you can clearly see here. I don't know what to say anymore.
pretty self-explanatory.
Yes, you don't build with bricks here, so it was all bricks.
Once you see the melted bricks, you won't fall for their tricks, guys.
No,
Right.
Sorry, but that's the way it is.
there's a picture I want to
Look at that.
Yeah.
So the ground's completely cooked out.
Yeah.
That's gone. The heat comes up from the bottom. So there's a lot of places where you don't see the brick anymore. It's just completely cooked out to dirt. Sometimes you'll find a little brick here and there on the ground. But for most people coming into a place like this, they just think the ground is dirt and that's all that was there.
Right.
But everything was bricked out, guys. Everything had brick. The streets, the floors. I've been in old world parking lots in Spartanburg that have been half paved over by asphalt, and you can clearly see the brick all over the ground.
Look at the base of that arch.
Yeah.
You see those bopping out on the left and the right, those block lines, dead center pick.
Mm-hmm. Yep.
This is what the mud flooders would call the mud flood building. But they don't explain what is this mud, you know?
Right.
It came from the building, or maybe the building behind, or the building, a bigger building. It's
We like to call it a brick flood.
yeah, we like to call it the brick flood. I wanted to show you a picture of the streets. Jen, come in. Making like breaking off and turning to stone. Oh yeah, this you can see like tunnels like this, but this one is really telling.
Wow.
Yeah, look at
Nobody put these stones there.
Balloon Rock City.
Yeah, Balloon Rock City.
It was a little hard for me to wrap my head around it at first when I was seeing these bigger blocks and stuff, and I didn't fully understand the levels of heat damage and what happens to this brick. And it took me a little bit to get to it, but the more research I did, the more digging I did, it became apparent to me that this is what was happening.
What made it for me is the picture of Mark had. Do you still have this picture, Mark? You can see like the balloon and 3 bricks popping off of it. Just crazy.
I'm trying to think of the one you're talking about. Yeah. Oh, yeah. I know what you're talking about.
It's like a dark black.
This one's perfect. This is perfect because look at this. This was all red brick, guys. Now look at the ceiling. The ceiling looks like what you would see on the streets of Pompeii. The ceiling looks just like cooked out what they call like a volcanic rock or something, okay? And that's identical to the worked out weird shaped stones that on the streets of Pompeii.
You know where this place is? Is the other side of this place.
Oh, really?
Yeah.
Wow.
Yeah.
That's incredible.
And this place, the same place, this place as this place.
That's incredible right there. Wow.
Look how thick that wall is. Look how thick that is.
It's all full brick.
Yeah, if that would have all melted away and a little piece of that wall was still there, they'd tell you it was a windbreaker.
Yeah, if we could break this wall, we would see like stones in it. Probably because inside it's superheated.
Mm-hmm. Well, look at the scorching up top there in the run.
And this drip. But now we will show like the perfect example.
Yeah.
We really like to show it. But I found new pictures of this place. This one we probably never seen. Look.
Yeah, I was about to say, I don't think I've seen that one.
No?
Okay, so let's tell people where we're at here for people who don't know, because we're all familiar with this location.
You want me to say the name? It's Fort Zverz, yeah? I don't even know.
Yeah, it's like Fort Verez or something like that.
Yeah.
It's in Russia, and supposedly this fort, on the historical narrative of it, is that in the 70s, there was some type of a napalm accident that took place here in this fortification where they were storing this type of liquid. It exploded. and temperatures were upwards of 5,000 degrees, okay, or somewhere between 3 and 5,000 degrees. And here you are seeing melted brick. Whether this was the X Factor or actually a napalm event, the point here is that we're showing you what extreme heat does. Rapid extreme heat event takes place and what it does to brick. This whole place was brick, the ceiling, the walls, and the floor. But now the floor looks like cooked out just dirt when it was actually all red brick, guys.
And sometimes they'll drip out of the around or in between the mortar too.
And those arches are a lot taller. That's all sunk. That's all brick ash.
Yeah. And also, even no matter how damaged it is, you can always make out the brick lines and the rows and rows of where they were, the pattern.
Here, this one you can see even the mortar still attached.
Yep. Now, this solidified mid-drip. It was in the process of dripping down, and it stopped. The heat was taken away, and there was some type of cooling process that take place, clearly.
Yes.
The energy discharge stopped.
Yeah.
It's like a breaker going off.
Yep.
Right.
Melted like wax.
Mm-hmm.
And here you can also see parts where the brick was, but now there's just an indent where the brick used to be. It melted out of its spot, and now there's just an indent there of where the brick was. You see that all over Vesuvius inside the supposed caldera.
And I would point out, like here, you can see like the bricks are breaking off and creating smaller pieces of bricks that we call rocks now.
Mm-hmm.
Mm-hmm. And the floor is just completely gone. It just looks like dirt now, you know, but yet it was all red brick at one time, guys.
Yeah,
All cooked out as closest to the melt, to the heat
Mhm.
coming up from the bottom.
That's right. Just so you guys know, I don't buy this historical narrative that this was some kind of accident in the 70s. I think this place was out on an island that nobody goes to. But people started to re-inhabit this place and maybe reuse it and decided, well, they have to give a narrative to it. 70s, napalm was around with Vietnam and all that. So this would be an incendiary that they knew that could get upwards of 3,000 degrees and that's what could do this to this. So they'll use that as a historical narrative. I could be completely wrong. Maybe that is what really happened, but this looks way too much like all the other shit we see everywhere else. And
Yeah.
look at it. You could see the brick was running down the fucking wall.
Mm-hmm.
It's crazy.
Napalm would have burned it from the face of it in. This is coming from the inside out as far as the melt goes. So that narrative's bullshit.
Yeah, it's just like we see, you know, have a shell of a brick and then the insides are all cooked out.
Yeah.
More heat damage is kind of what we're seeing here. So.
Yeah.
This is the perfect example to show that brick can actually melt like this. So.
Here's a good example of how the rock goes block. I mean, the brick goes block, and it looks like just big chunks of rock now. See, these were nice bricks, just like the other spots that we saw and everything. But now they've expanded into each other. They've churned around. Some of them have turned upside down and on their sides. Other ones form nice squares next to each other and stuff.
Y'all remember that picture you just had, Shapu, at the top? All those little drippies, white. Remember that? I'll show you another one.
Yeah, that mortar schnot.
Yeah, looks just like that.
The same place that I show you with these balloon rocks. This is the same place. If you continue, you will go to the blackish one that I showed you. And this place is this place, inside of this place.
Wow.
Yeah, it's in there. I don't know where, but you can clearly see. Just show you one. Oh, sorry. This one. Show you, you know.
Yeah,
see?
look, you can see the brick in what looks like a massive rock wall, but it's not a massive rock wall. It is just a brick wall that has melted down over itself and it's formed some type of a rock curtain over most of it, but you can still see those bricks right there.
Yeah. Didn't quite cover it up.
No. You can still see that this was brick too.
Mm-hmm.
Probably all refurbished later. But this.
Next time you're rolling down the highway, pay attention to the rock walls that you see along your highways and little side roads, windy roads and stuff. All those were melted buildings, guys. It's not some natural rock formation.
Yeah. And most of your underpasses on bridges, railways, all of that, you look at the bases, it's old world. It's all X-factored.
Mm-hmm.
To show you, this is the same place again. Another wall. Look how the heat came in and squeezed the wall.
Wow.
This place. Look at the.
So again, here you can see the heat comes up from the bottom. So all the stuff on the bottom is cooked out more than the above structure where you can still see the red brick.
Yeah.
Now, if that would have kept going, right, and it didn't stop, that bottom portion that we can see that's all cooked out probably would have melted away more, and the structure on top, the arches, would have started turning that color, the gray, but it would have been squished down over top of this well-looking thing here. That would have all melted away if the heat kept going, but it didn't. It stopped.
You can see that these rocks came from the inside, and the arches are always the last part to be changed.
Yeah, the arches make out really, really well. Even Dean over here, Fervent Heat, has found apertures of arches and stuff off the coasts of these islands and stuff. They seem to really hold up well, even in their most destroyed state. We saw that one arch a few pictures ago that was barely standing, but it was still there.
Right.
Now look
the
at
arches
that.
seem to dissipate that electrical energy because of their shape. You know, they transfer that kind of like the arches.
I was just going to say to stay on this picture, Shapu. Go ahead, Dean. I'm sorry. I didn't mean to cut you off.
Oh, no, that's fine. You know, a lot of the arches, you'll see them, they'll be, angled, wavy, that's because of the heat, the buoyancy, the density, the expansion, but they discharge around those arches. So, that's why you see this kind of effect right here.
Mm-hmm. Now, this wall looks like a cobblestone street, don't it?
Exactly. Yeah. On a bigger scale. Yeah.
So did a street just pick itself up and slap itself on the side of this wall? I don't think so. Look, there's some nice brick that survived in the middle of the wall. I mean, how's that? What's going on here?
Yeah. Same place.
I agree, Darren. We can't really even imagine what this place must have looked like before. But clearly, all of it was made of brick. At the very base of it, it may have had facades over it, even some type of cement facade moldings over most of the building. But underneath, after all that shit melts away, you're left with brick. And then the brick starts getting heated up. And look at what we have here. We have a half melted brick. I mean... There you have it. You can even see the shine on it when it's shining.
The glazing. Yeah.
Do you want to explain, Dean? You want to explain this glazing effect that we see here?
Yeah, that's the heat, the expansion. You're getting that the state of matter changing. It's so hot you can see the viscous holes. See how it's porous? Mm-hmm. Look at the scorching right there with the viscous holes on it. Okay, you get that heat, and it's just like it's red brick. It's rekilned, you might say. You get that glazing effect from that heat expansion. Anymore, and it's going to go more scorching, more white, cooked out, and then eventually you get sand, brick ash.
Yeah. And if you go to Sodom and Gomorrah, that's a good example. You've seen videos of people walk up to those walls there in Sodom and Gomorrah, and it just crumbles away. It's so cooked out that it's literally building ash now that's just barely standing there. Now, this is a dry, arid area where Sodom and Gomorrah is. If Sodom and Gomorrah got hit with a massive rainstorm that lasted for 40 days and 40 nights, I guarantee you Sodom and Gomorrah wouldn't be there. It would wash away down somewhere and over some town. And there's your fucking mud flood.
Yeah.
Look at this, guys. I mean, go back to that last picture, Shapu. Yeah, that one there. Look, guys, this was regular brick, just like the bricks next to it, but these bricks went block. They melted into each other and formed larger, squarish looking brick.
Yeah.
I mean, I don't know what else to tell people.
Can you go back to the picture before that one, Sheepu?
This one?
Before that one, just one more.
This one.
Yeah. Look at that brick right there in the bottom right.
Mm-hmm.
In the center.
Yeah.
That's your beginning of your balloon rocking.
Yeah.
Yeah, it's just starting there, guys. The whole thing would balloon. Now, just the center part was coming out, maybe between two bricks or whatever, but it's coming out, or it was one brick. It's starting to come out, but the whole thing can expand out. And then some of them will actually jut out from the wall. The pressure of whatever's taking place with this heat event, it starts to look like this, where the brick starts getting all twisted and deformed and popping out.
Mm-hmm.
Yep. Doing magic tricks.
Yeah. Then some people will say, "Oh, they're just clinker bricks," but you can buy some clinker bricks, but they're not like this. They're not like this. Like this.
Wow.
Yeah.
Now, see, here's a good example of after the heat event and everything cools down, it solidifies and it hardens up. It's molded together at this point. It would be hard to push this wall over and destroy it because it looks like it's all janky and about to fall apart, but it's actually not. It's solidified together and it's all like a crazy glue on the inside.
If you look back at that last pic, you can follow those lines, those block lines, and it was leaning backwards.
This one. No.
Is that the one?
No, this one.
That one.
Yeah.
So look at those block lines. You're starting to see it's leaning backwards. It's the buoyancy and density. It's getting viscous and it's starting to tilt backwards. That material is starting to settle on itself and going backwards, leaning at a tilt.
Somebody's asking, what is a little season? I'm not sure what a little season is. It could be 200 years. It could be 300 years. I'm not sure. If you're referring to the golden age and the short season that Satan is loosened for a time, which I think we are in that short season, by the way. And if you put the X Factor event back, if it's a cyclical nature, say 300 to 360 years, and then, Satan comes out and he's loosened for a short time. Maybe we're in that short time now after that last X Factor event. Whatever this place was before the X Factor event, these people had their shit together. Clearly there wasn't war and poverty and all that crap like that. It seemed like everybody knew what they were doing and they had their shit together and everything was built out. This was a well-advanced, well-established civilization that was take place prior to these X Factor events.
Yeah.
Yeah.
And with the intricate, with everything that they look like, from what we can still see in the evidence, it was so amazingly wonderful. You couldn't have created this out of a war mindset, out of the mindset that we have now.
Oh yeah, no, we see what we create nowadays. Just take a ride down any street, go past strip malls and stuff. This is what we build today. We are the disposable civilization that's here.
Yeah.
If an X Factor event hit tomorrow, all our shit would be gone instantly. This shit would probably still be here.
This is
I'm glad you showed this show.
This is what geology tells you. They show you it was like a brick.
Yeah.
Oh, look how it became this by erosion, but
Yeah. Why did it all erode differently? That's just, I saw this. I'm like, really?
yeah.
Geologists should be fired immediately, if not sooner.
Like this. You can see that this is the same as this, but you can clearly see that this one was built with blocks, but this one cannot see any of it left. Hit differently, But I want to show you, Jen, that the roads, again, look at these pillars. They're all made of bricks.
Yeah.
Pillars made of bricks. And I want to do a show, Jen, when we look at the Athens Acropolis. Because I think it was totally different than what they are now, because they have built it and rebuilt it and changed it, and it wasn't like that at all. I found some really old pictures that wasn't everything was destroyed. There was only pillars and other type of construction that looked like more medieval type of
Uh-huh.
things, but they changed it into Greek Roman.
Interesting.
Yeah,
I wouldn't put nothing past these fuckers. They're manipulating everything to fit his historical narrative.
yeah.
Yeah.
They've rewritten everything and changed the names of everything. I mean, we just saw a map the other day on our live stream where Tartary was up in Alaska.
Yeah.
And Japan was massive.
Yeah, exactly. So this one you can see. Look, this the same place. This is one side. This is the other side of this.
Brilliant pick, Sheepu.
You can clearly see the different
Look at the
damage.
brick on the ground, guys. Look at the brick on the ground. So far we have laid the foundation for you guys to see what we're talking about, how brick turns into what people call stone, right? How it gets this glazed effect over it, how it melts into each other and forms bigger blocks of brick. And now here you even have a melted brick road.
Yeah.
Let's go back to that last picture real quick. Yeah. Can we zoom in on that a little?
Yes.
Yeah, I want to focus on the brick right there. Look at that. That's not a cobblestone road, okay? If you got cobblestones on the brain, you need to go check yourself before you trip over a brick and wreck yourself. That's a fucking brick road all day long. It's just melted, like the walls and the bridge and everything else.
That's stripping material for sure.
Right?
A lot of speed bumps on that road.
Yeah. Gonna ride your cart down there? Yeah, okay.
You know, a lot of these things we call roads, these are the tops of melted buildings. These were walkways.
I agree. Like a lot of the places, like the Great Wall of China. That's just the top of the building that's already melted down out and away from itself. I always said that these buildings were massive and they were interconnected. You never even had to go down the ground level. We don't even know where ground level is, guys.
Just like a motherboard, you keep, connecting stuff to connect everything, basically, so my thoughts, you're building these buildings, you just keep building it on each other for the free energy and everything. So
exactly. Now look at this. This is interesting here because Egypt, this is what's this place called? Namibia or something like that. It's in Egypt. Yeah. So here we have deserts. Okay, guys. So these deserts are just the rest of the buildings that have been cooked out to sand. Like they're completely disintegrated down. And when you look at Africa and Asia, going in over towards Russia and China, you can see a massive scarring event that took place on our plane due to probably the X Factor event where the motherboard itself, the grid system that we live in, was hit extremely hard in these areas. Extremely hard.
Yes. And we've done extensive research over that area and come up with analysis of, the X factor. And part of the reason with the sun being involved in all of this, obviously, the sun-kissed analysis that we broke down with Stefan in the Eli crew and Melted Red Brick University.
Okay, so let's explain this because I haven't really heard this theory. I've heard people kind of snicker at the theory. I haven't actually heard the theory yet. So let's lay it out for everybody.
Well, I'll try to make it quick because Sheepu's got some great stuff coming right here. The analysis, you look at that region over China and the amount of melt, the mass of that melt and the flow of it and it covering up actual structures that were there, rock curtaining over them, shows that a huge event happened there. In layman's terms, a sun kiss. The actual sun dropping to a point in its path and its rotation.
It goes
and
with
causing this effect. Now, this is an analysis, okay? But the evidence shows that this kind of event, that's a top explanation for it.
Yeah, it goes with our theory of the pole shift.
Yes.
Yeah.
It all comes in. Yes, exactly.
Look at the bottom part of this.
Yeah.
You see that something just hit the top part, but that didn't hit the bottom. So this is what I told you, that somebody tried to destroy this place, but really couldn't.
The whole right side of it's sliding down. It
Yeah,
melted down to behind the other. But
yeah. So this was a big structure, but now just one piece.
Yeah.
But I tried to find my pictures of the roads that I want to show Jen.
I'm right here.
Yeah, I know you're here.
I'm sorry.
I'm not where I want to show you the pictures. Look, this place, look, it's the same. Another place in Russia, kind of look like Fort Zertsev. It's another fort, Fort Tarakanawi, something like this.
Yeah. Yeah. So you could see how the building even looks like it's kind of crushed down on itself. The part of the building's melted out away from it there, but the ground's all gone. Whatever brick was on the ground is melted away.
Yeah.
Yeah.
Oh yeah, I like this place because it's got so many different levels of heat damage. It's a perfect place to take people or to show people the different levels of heat within a structure.
That shows you, that last pic right there is an excellent example of the electrical discharge through that piece right there, through that part of that structure.
Yeah. It goes around the arches.
yeah.
But the arches, they still stand up, though. It's amazing to me how well they do.
But, they do get filled in a lot of the evidence, a lot of these the so-called cliff faces, you can see actual arches in the melt, and then you can see ghost arches. You can see where it expanded from the inside out, and actually, like toothpaste, went to its the path of least resistance and pushed out to where you just get the imprint of where the arch was, and the only way you can see it is the differential in the melt.
Yep.
Hopefully by now, all of you have seen this video by BMLSB69. His observer height is only 1 foot. Now that first platform is 6.2 miles away, and platform habitat is 9.4 miles away, with the horizon far in the distance beyond that. Now I'm going to let you just sit there and take this in, because this is the absolute #1 globe killer. Modus tollens states, if P, then Q, not Q, therefore not P. If P, we live on a globe of radius 3959 miles, then Q, every horizon distance measurement cannot be more than 1.23 miles times the square root of the observer height in feet. Not Q, the geometric horizon is far greater than 2.73 miles for 5 foot. Therefore, not P. The Earth is not a globe. But this valid logical conclusion is hand-waved by the globe zealots as word salad, so I'll put this devastating picture in simpler terms. Globe believers must have a physical leading edge, the geographical edge to their sphere, in order for boats to go over it and for land and water to curve around it. It's a fundamental pillar to their religion. If the globe they presuppose has a radius of 3959 miles, then the horizon distance is set by the height of the observer. So what makes this image so devastating is the height of the observer at only 1 foot. The horizon should be 1.22 miles, but even if we set it at 5 feet, the horizon should be 2.73 miles. But we can see the bottom of platform habitat where it meets the water 9.41 miles away, and the horizon above that beyond in the distance, making it fundamentally impossible to see this from 1 foot on a globe.
I'm claiming what every single glober here claims. The Earth curvature is not the horizon. It's not Earth curvature.
Nathan, this observation looks the same every single day. The weather has nothing to do with it.
And every time you see the horizon, you're actually seeing the geometric horizon.
We are not going to see the geometric horizon.
No one's claiming that we see physical geometry.
It's not a visual horizon.
And every time you see the horizon, you're actually seeing the geometric
horizon is the one that you see.
And the geometric one is the one we don't see, because if we don't see it, it's not a horizon.
It's not a visual horizon, but it is.
So we don't
visible.
see it, so it's not a horizon.
Not a horizon. You are correct. We do not observe geometric horizon.
Welcome to Flat Earth.
Changed by refraction. Do your eyes always tell geometric truth? The short answer to that last question is no.
At best, you would have disproved the radius of the Earth. Back to Mitch, though. I did a debate with him on Fight the Flat Earth, and there's a certain part of that debate that he has used and has been spread to other channels. And I think I just need to clarify something a bit. So if the Earth is radius 3959, then the geometric horizon can only be 1.22 miles times square root of observer height in feet, which I agree with. So if you could show that the geometric horizon is not at that distance, not Q, then the Earth, P, is not a globe of 3959 miles. That's all you will have proved.
Mr. Sensible gets it. Finally a glob that understands the black swan argument. And through knowing the argument, what's the conclusion?
It would be a different diameter. Perhaps 3960 or 3961. You complete and utter twonk. Okay,
So unless you
so
assert that the globe has a bigger radius.
Exactly, that's what I was going to say. At best, what you have done, if that was all correct, at best, Mitch, I was very careful in what I said. Those penny drop moments were when I was being very sure about what you were saying. And I'm very clear here that at best, if everything you said was correct, and it wasn't, then you'd have disproved the radius of 3959, i.e. it would be a slightly different radius.
A slightly different radius? Well, let's do the actual maths then. Here it is set out for everyone to go over in your own leisure. Using the values from the black swan image of a 1 foot observer height and a 10-mile distance horizon, you can clearly see we have a 264,000 mile radius. But isn't the radius of the sun meant to be 432,000 miles? No, not anymore. It's got to be bigger now. What about the distance to the moon? 238,000 miles. Nope, that's got to be different too, doesn't it, Mr. Sensible? What else does it implicate? The radiuses of all the planetary orbits have to be different too. But that can't be right, can it, Mr. Sensible?
I was correct. I was absolutely clear. At best, you've disproved the size of the Earth, not the shape of the Earth.
Every time that you keep doubling down that your radius is larger than that of the mainstream accepted value of 3959 miles, you stab your globe in the face.
You're right. It could be flat.
Refraction is looming the horizon behind the platforms in the Black Swan. You stab your globe in the face.
You're right. It could be flat. And I think I just need to clarify something a bit. Horizon isn't a physical thing. It's just the point at which geometrically the tangent that you're looking at towards the surface of the Earth. So that red area right now is hidden behind the horizon, the physical geometric horizon.
Behind the physical horizon.
Yeah.
Yep. Higher in elevation than it usually is.
The horizon isn't an object. It's just a point a certain distance away from you. I mean,
Correct.
The blue area.
Not Q. We don't have a geometric horizon. Then not P. The Earth is not a globe.
We do have a geometric horizon, we just can't see it, but perhaps we better agree to disagree. But I would like to see that butane experiment done again. There is no, the horizon, there is a geometric horizon, but if you walked forward 6 feet, the geometric horizon would move away from you by 6 feet. It's not an exact point, it's just a distance.
So that's apparent. It changes. But can I ask you, if it is an apparent location, the horizon, what is cutting off the bottoms of those ships?
On occasions when you see that, the ship is beyond the geometric horizon, and the amount of refraction is not enough to lift them further into view. So the geometric horizon is hiding them.
So we can see the geometric horizon on some days?
We do have a geometric horizon, we just can't see it, but perhaps we better agree to disagree. But I would like to see that butane experiment done again.
So we can see the geometric horizon on some days?
No, it's hidden behind the water, but there's not enough refraction to lift the image of the full ship above that apparent horizon. At best, what you have done, you would have disproved the radius of the Earth.
Andrew Young cites geometric horizon as where the apparent horizon would be if there were no refraction, equivalently where the cone with the vertex at the observer's eye and tangent to the sea surface.
So you said the geometric horizon is what? That refracted?
It's where the apparent horizon would be if there were no refraction.
Okay, so it is the horizon that we see, because there's only one horizon. The horizon is the refracted horizon, correct?
No.
That's what you just, I'm sorry, you just said that.
No, it's not. No, it is not.
Going round in circles.
Yeah, that's what you just said, Brenda.
We don't have an apparent horizon and a geometric horizon. We just have a horizon. It's just not geometric.
Correct.
Yeah, well then, welcome to Flat Earth. You've just made it plain we don't have a geometric horizon. So what geometric position, moron? You don't have one!
We do.
Oh, so now we do. Only 30 seconds ago, ladies and gentlemen, he made it plain we don't have a geometric horizon, and now we do.
No, we don't have a geometric horizon.
You seem to be double flip-flopping.
We have got geometry, and it's...
No, we haven't. We've demonstrated a geometric impossibility in the black swan image. Ergo, you don't have a geometric horizon.
No, we don't have a geometric horizon.
Yeah, see, there he goes again. Can't seem to make up his mind. He needs a geometric horizon for his Earth curve maths, but we haven't got one according to him. You've lost. So we definitely don't have a geometric horizon.
I didn't say we did.
It looked like a star in the heavens.
Seth Putterman called it the star in a jar, a tiny spot of bright light contained in a flask of liquid. This star in a jar is made when a sound wave is passed through a small bubble inside a flask of liquid. And this sound wave makes the bubble do something remarkable. First it expands, then it collapses. And this collapse happens so violently that vapor molecules trapped inside the bubble slam together and heat up so much that the bubble gives off an incredible burst of heat and light. Several thousand times a second, giving the appearance of a star.
absolutely amazing. And to describe it to you from, I mean, you can see it, but from the ground, it almost looks.
Also, the phases of water. Now, we've all learned that there's a solid phase, a liquid phase, and a vapor phase. However, 100 years ago, there was some idea that there might be a fourth phase somewhere in between a solid and a liquid. Sir William Hardy, a famous physical chemist, 100 years ago exactly, professed that there was actually a fourth phase of water, and this water was kind of more ordered than other kinds of water, and in fact had a gel-like consistency. So the question arose to us, you know, all of this was forgotten because people began, as methods improved, to begin to study molecules instead of ensembles of molecules, and people forgot about the collectivity of water molecules and began looking, the same as in biology, began looking at individual molecules and lost sight of the collection. So we thought, we're going to look at this because we had some idea that it's possible that this missing link, this fourth phase, might actually be the missing link so that we can understand the phenomena regarding water that we don't understand. So we started by looking somewhere between a solid and a liquid. And the first experiments that we did that get us going is we took a gel, that's the solid, and we put it next to water. And we added some particles to the water because we had the sense that the particles would show us something. And sure enough, you can see that what happened is that the particles began moving away from the interface between the gel and the water, and they just kept moving and moving and moving, and they wound up stopping at a distance that's, well, roughly the size of one of your hairs.
Is this why this image is so clear and the bubbles are so clear? Because all the particles have been moved from the EZ water, the fourth phase of water.
Now that may seem small, but by molecular dimensions, that's practically infinite. It's a huge dimension. So we began studying the properties of this zone, and we called it, for obvious reasons, the exclusion zone, because practically everything you'd put there would get excluded, would get expelled from the zone as it built up, or instead of exclusion zone, EZ for short. And so we found that the kinds of materials that would create or nucleate this kind of zone, not just gels, but we found that practically every water-loving or so-called hydrophilic surface could do exactly that, creating the EZ water. And as the EZ water builds, it would expel all the solutes or particles, whatever, into the bulk water. And we began learning about the properties, and we've spent now quite a few years looking at the properties. And so it looked something like this. You have a material next to water, and these sheets of EZ layers begin to build, and they build and build, and they just keep building up one by one. And so if you look at the structure of each one of these planes, you can see that it's a honeycomb, hexagonal kind of structure, a bit like ice, but not ice. And if you look at it carefully, you can see the molecular structure. So of course it consists of hydrogen and oxygen because it's built from water. But actually, they're not water molecules. If you start counting the number of hydrogens and the number of oxygens, it turns out that it's not H2O. It's actually H3O2. So it is possible that there's water that's not H2O, some phase of water. Say this is a lizard from Central America, and because it walks on water, it's called the Jesus Christ lizard. And of course, you'll say, well, I know the answer to this. The surface tension is high on water. But the common idea of surface tension is that there's a single molecular layer of water at the top, and this single molecular layer is sufficient to create enough tension to hold whatever you put there. I think this is an example that doesn't fit that. And here's another example. 2 beakers of water, you put 2 electrodes in, and you put high voltage between them. And then what happens is a bridge forms, and this bridge is made of water, a bridge of water, and this bridge can be sustained as you move one beaker away from the other beaker as much as 4 centimeters, sustained essentially indefinitely. How come we don't understand this? So we began looking, of course, more into these extremely interesting properties. And what we found is we stuck electrodes into the EZ water because we thought there might be some electrical potential. It turned out that there's lots of negative charge in that zone. And we used some dyes to seek positive charge, and we found that in the bulk water zone, there was an equal amount of positivity. So what's going on, it looked like, is that next to these interfaces, the water molecule was somehow splitting up into a negative part and a positive part. And the negative part sat right next to the water-loving material, and the positive charges went out beyond.
So this EZ water is highly negatively charged. So if a blob came off there, because there's no atmosphere at the top near it, it would fall at great speed. And when it got to a bit thicker atmosphere, which is positively charged, it would slam into the positive energy atmosphere. You get a positive and negative together, you get plasma. So if a blob came off, it would fall at speed, slam into the positive atmosphere, and you would get a ball of plasma, shooting stars and meteorites, which would answer that. So that's another supporting evidence that the firmament is a 4th phase of water.
I know we have still not shattered that highest and hardest glass ceiling, but someday someone will, and hopefully sooner than we might think right now. I can't believe we just put the biggest crack in that glass ceiling yet.
Compound in the whole world. 99 out of every 100 molecules is this one. And water is the major thing on everything on this planet. And that should be the ultimate focus of a place where we can clean up and make a significant impact. But now let's talk about those chemtrails which spray out and then diffuse out. And by the fact that I was in the movie What in the World Are They Spraying with Michael Murphy back about 6-7 years ago, I became noted as the resident expert. And the 3 things we're really worried about are barium, strontium, and aluminum. And actually, the form that they are in the sprays are as the oxides. So we have barium oxide, strontium oxide, aluminum oxide, but notice aluminum oxide is Al2O3. And that's because the aluminum with its 3+ charge has to be balanced but to the oxygen with its -2 charge. And so to get these balanced, that's why we need 2 aluminums and 3 oxygens. And this is called alumina, and that's one of the major components of what they're spraying. So why are these 3 the big bad guys? Let's talk about barium and strontium first. Now, actually, let's talk about barium and strontium first. Let's blow up this part of the periodic table that we had. And here you have sodium and potassium, lithium. You get barium and strontium down here. And so these are +1 guys, and these are +2 guys. Well, above the barium and strontium are things like calcium and magnesium. Now, we know that calcium and magnesium are very important to biological systems. And it turns out that the way the periodic table works is that when you're high in the periodic table, towards the top of it, we're talking about small molecules, and as you get down lower, you're talking about bigger and bigger molecules. So lithium's a nice small molecule, sodium's a little bigger, potassium's bigger, and these all have 1+ charge. When you get to magnesium, magnesium with a 2+ charge is actually a little smaller. Well, you know what? Magnesium's on the wrong row because it's actually supposed to be on sodium's row. But it's 2+ charge. Magnesium is a smaller ion than sodium because being right next to the periodic table, you've got positive charges in the middle and electrons that are negative charges around the end. And to get these positive charges, you release electrons. If you've got 2+ charges, all the rest of the electrons are pulled tighter into that nucleus. So even though you think this is bigger, it's not. It's really smaller. And so what happens when they spray is that in biological systems, well, what's a biological system anyway? Everybody has a, okay?
I'm one.
In fact, every biological system is different, but it's usually made up of the same stuff. And the major component of a biological system is water. But copacetic. Now, magnesium is fairly small. Calcium is about the same size as potassium. Strontium is a little bigger than calcium, and barium is a little bigger than strontium. But you see, if we were to substitute a strontium in for this magnesium, and you know, that's what I think we're doing with the chemtrails, so we put strontium in it. Now, this is a bigger atom than was in it with the atom that belonged. And so, because of that, that's going to push this out of whack. This is going to have to be back here, and it's going to start breaking bonds and causing chemistry because you're putting a big molecule in place of something that was smaller, and everything has to spread out to accommodate it. The barium is even bigger than the strontium, and so now you can see when you get a barium into the lattice, first, it displaces a whole lot of things in the lattice. Second, it hangs on better so that you can't get it out of the lattice once it's there. So as where normal chemistry might have calcium substituting in for another calcium, and that'll work for a little while, and then another calcium will come in. Once a strontium or a barium comes into a porphyrin ring, it gets stuck. Now, yes?
Why are those getting substituted? What is it that's allowing? I mean, we're surrounded with all kinds of metals and chemicals all the time. Why are those getting sucked into the ring? Why is
this is an example of how the specific mechanism of a ring was only chosen because it's convenient to talk about. We could easily substitute it onto this molecule down here, in which case we have a calcium which is a lot bigger than the sodium, but here at least it's on the end of the molecule and can get swept off. The real problem with it is that, as I said, these things form as oxides, and they're stable in their charged form as oxides, and so when they stick to an oxygen, they think they're in their normal inorganic place. They're not really ready to go leaving the site they're at, and that's what holds them in, is the fact that the bigger molecules have a more finite attraction for the site than the smaller molecules do, and so the smaller molecules can't knock a bigger one out. Eventually that does happen.
Is that gravity?
Not necessarily. I think it a lot has to do with the size of the fit and the cavity that it's in and how much distortion it caused in a molecule. Because if you twist a molecule and it really is out of shape, the forces to put it back into shape are going to kick that off. But if you just make a subtle change and you make everything loose, what happens is that the components that get loose don't function as reliably, and so your mechanism for doing something like breathing and intaking oxygen might slow down because you've got things cluttering some of your sites because they wouldn't let loose like the molecule was supposed to.
I'm no expert in chemistry, but what I was picking up from this talk was the changing of a smaller atom for a bigger atom will distort the structure, making it weaker.
What the fuck? What the? Fuck! Shit! Fuck! Shit!
Absolutely amazing, and to describe it to you from, I mean, you can see it, but from the ground.